In this video, we're going to talk about performing significance tests to compare to means, to population means. Okay, so our significance tests, we know we're going to have a null hypothesis, of course. And in this case, it would be mu sub 1 minus mu sub 2 equals some number. A lot of times it's 0, doesn't have to be 0. Okay? But that's often what we're interested in. It could be some other number. Okay, so it could be or mu sub 1 minus mu sub 2 equals some number. But 0 is one we use oftentimes. So we're going to use 0 and then just know that another number might take its place. So the alternative could be one of three things. It could be that it's mu sub 1 minus mu sub 2 is less than 0. Mu sub 1 minus mu sub 2 is greater than 0, or mu sub 1 minus mu sub 2 is not equal to 0. Of course, the two-tailed test there, if that's what we're doing. Now, if we want to, of course, if conditions are met, we would have our t statistic in this case would be x bar 1 minus x bar 2 minus mu sub 1 minus mu sub 2 divided by square root of s sub 1 squared divided by n sub 1 plus s sub 2, the standard deviation of the second population or the second sample, divided by n sub 2. Of course, there's lots of chances to make little mistakes here. And if we actually are going to do a significance test for this, we would probably just do it with our two-sample t-test. Two-sample t-test. Two-samp t-test with the calculator, and that we get by going to stat over the tests, okay, and then number 4 is two-samp t-test. Okay, and we always report out. We're going to report out three things: the t statistic, the t-value, the p-value, and the degrees of freedom. The degrees of freedom. Okay? So we tell them what we're putting into our calculator, and then we report out those things. And we have to report out those things if we want to get full credit here for doing our work. Okay? So let's look at an example. After buying many helium balloons only to see them deflate within a couple of days, Aaron and Jenna decided to test if helium-filled balloons deflate faster than air-filled balloons. To find out, they bought 60 balloons and randomly divided them into two piles of 30. Okay. Filling the balloons in the first pile with helium, the balloons in the second pile with air. Okay. Then they measured the circumference of each balloon immediately after being filled, and again 3 days later. The average decrease in circumference of the helium-filled balloons was 26.5 centimeters with a standard deviation of 1.92. The average decrease of the air-filled balloons was 2.1 centimeters with a standard deviation of 2.79 centimeters. Do these data provide convincing evidence that helium-filled balloons deflate faster than air-filled balloons? Well, let's do our solution to that. Okay. So our null hypothesis would be that there is no difference. Mu sub 1 minus mu sub 2 is equal to 0. And our alternative hypothesis would be that mu sub 1 minus mu sub 2 is greater than 0, where mu sub 1 equals the average, or the mean. I'm going to use mean instead of average. The true mean decrease in circumference of helium balloons. Okay. And then mu sub 2 would be the true mean decrease in circumference of air-filled balloons. So if conditions are met, will conduct a 2-sample t-test. Okay. Conditions. Okay, first of all, random. The data comes from 2 independent random samples. Right? Or two random samples. 10%. Right? So for both, 30 times 10 equals 300. Okay. Okay, is less than all balloons. And then large sample, N1 is greater than or equal to 30, and N2 is greater than or equal to 30. Okay, so we're comfortable using, now for our calculations, we are going to use 2-sample t-test, and we're going to put into it x1, which was the 26.5, and 1.92 was the standard deviation, and then x2, which is the 2.1 with a standard deviation of 2.79, and we're going to put that into our calculator. Number 4, and enter the stats, and we've got it, the numbers not quite right, and this and N1 is 30. X2 is 2.1, and the standard deviation was 2.79, and N2 is also 30, and we want greater than. Mu sub 1 is greater than, so we're going to go pooled no. We always say no to pooled. Calculate. So our T equals 39 point, get that back, 0.460, and our P value is pretty much going to be 0. You can see e to the negative 40, so our P value is 0, and our degrees of freedom is 51.435. with our calculation. That's what we report out each time. And now finally our conclusions. Because our p-value equals 0 is less than the alpha 0.05, we reject the null hypothesis. There is convincing evidence that helium-filled balloons inflate faster than air-filled balloons.